So the second half of 4.1 talks about one tiny application of exponential functions, and that application is compound interest. Well, what exactly is compound interest? Well, we'll get to that eventually, but I want to build up a basic idea or make sure to confirm we have a basic understanding of simple interest. So suppose we have this hypothetical question. It shouldn't take a lot of math. It should be common sense. Suppose you deposit $100 into a savings account that gives you 5% interest. So clearly we're in fantasy land because no savings account will give you that high, but let's pretend. After 1 year, how much money's in your account? I didn't expect you guys to do a lot of math for this, so hopefully, again, you can just do this in your head. It's just simple thinking. I'll give you guys a few extra seconds to think about it. I'm just rambling on to stall for time, but I hope everyone got $105, right? Of course. Why? That's the better question. Why? We have our original $100 that we got and added $5 in interest. Now the key here is, how in the world did we get 5? Well, of course, that's the $100 that we started with times 5%, and I hope everyone understands or knows that 5% as a decimal is 0.05. Right? So that's basically, we should have an innate understanding of how to calculate regular interest. Now, this was specific numbers. $105 equals $100 that we started with plus the interest, $100 times 0.05. What I want to do is translate this common understanding into abstract symbols. So instead of saying 105, which stood for the total, I'll use A for the amount in my account. Now, the 100 here stood for the initial amounts. Now, in economics, we don't call it the initial amount. We call it the principal. So we'll use the letter P for the principal, plus 100 was the principal again, times the 0.05 was the interest rate, which we'll use the little r as interest rate. That right there, I guess I don't need the parentheses. That right there is the formula to calculate the amount of money I have in my account when I have interest. I actually don't want to write him like this because you guys notice how they both have P's in here. So since they both have P's, let's go ahead and clean them up. Let's factor out that P. So here we have the ultimate final formula to find the amount of money left in my bank account after 1 year. Right? After 1 year, I'll put a little subscript 1 here to indicate that's 1 year. Well, this is the idea. What if we don't touch this money? Right? What if we left all this money back in the bank account to be reinvested? Well, do you guys agree that at the beginning of the second year, this whole amount will be my new initial amount? For example, if we use our specific numbers, right? After 1 year, I have $105 in my account. If I just let it sit there, I'm now reinvesting $105. I'm not reinvesting just a regular 100 now. So if I follow the same idea, this will be our basic idea here. How much money will I have after year 2, A sub 2? Well, it's the amount of money I started at the beginning of the year, which you said was this guy, right? Everything at the end of year 1 is what we're going to start with in year 2. So that's what we start with, 1 plus R, plus we have to add the interest. And how do we do the interest? It's the principal, what we started with, 1 plus R, times the interest rate R. Well, just like before, when we notice, hey, these guys both have P, so we can factor it out. I hope you guys noticed that in year 2, we have 2 P times 1 plus R. They both have a factor of P times 1 plus R. We can factor those guys out to give us P times 1 plus R times 1 plus R. Because if we factor this guy out, the yellow, what is left over? You have a 1 here, even though you don't see it. And then you have this R here, so it's 1 plus R. Well, not a trick question. 1 plus R times 1 plus R, when you multiply something by itself, it is a square. That is very suspicious. When you only have it for 1 year, it's just a regular p times 1 plus r. When you have it for 2 years, it's p times 1 plus r squared. So without doing any math, can we sort of guess what should happen at year 3? P times 1 plus r cubed. After year 4, p times 1 plus r to the 4th power, and so on, and so on, and so on. So now it gives us a general formula at any given year. Let's use t for time. The formula for the interest should be p times 1 plus r to the time power. Right. So this is just an exponential formula with base 1 plus r. But again, I'm not interested in regular interest. I'm interested in compound interest. So what compound interest does, and this is a pretty neat idea, is that most companies, most banks, most institutions, they don't give you your money all at the end. Right? Because this formula suggests, if you deposit $100, in January, it'll still be 100. In February, it'll still be 100. Heck, in March, it'll still be 100. In November, December 31st, it'll still say 100. But the moment the clock ticks 0 for the new year, boom, magically you get interest. And that's not what really happens. Businesses, banks, they sometimes give you interest every month, every week, every day. So that's what compound interest is. Compound interest is breaking up the interest rate and distributing it or applying it over the course of a year. So it's sort of like, not dollars, 5% one time a year versus, well, what if I compounded it twice? So I'm going to chop this up into 2 bits. That's 2.5% twice a year. So some banks, some companies, instead of doing it all at once, all 5% one time a year, they may break it up into itty-bitty pieces, smaller pieces, but they apply it more times within a year. Right? So I hope if you guys understand this, how that changes our formula. All right, so this is a compound interest formula. The formula goes from this guy here to this guy here. And I'll write it in function notation. The amount of interest I receive in any given year is the initial amount I invested plus 1 plus r over n. So instead of being a regular interest rate, I'm going to chop up that interest rate into smaller bits. But the idea is that if you chop it into smaller bits, you apply it more times throughout the year. So for the exponent, instead of being a regular time, it's n times t. Right? And that should make sense. If I chop it up into 2 pieces, I apply the interest rate twice as much. If I chop it up into 10 pieces, I apply the interest rate 10 times as much. So that is the compound interest formula. Let's define what all these pieces mean. So I've already said A of t, that's the total amount. So that's the amount after t years. P, we said, was the principal, which is another word for the initial amount. R is the interest rate. But the important thing is, in order to do math, it has to be a decimal. N is the number of compounds per year. And of course, T is the number of years. So, although if you found that that derivation was too complicated for you, honestly, if you just know this formula and know what the pieces means, you're set. I'm not going to quiz you on where it came from, although I think it's sort of nice for you to know where it came from because it's very logical, but all I'm going to expect you to be able to do is use it. And typically for these problems, all it is reading, plugging in the numbers where they belong, and using a calculator. So for example, a sum of $1,000 is invested at an interest rate of 12% per year. Find the amounts in the account after 3 years if the interest is compounded, and this looks like a multi-part problem, compounded annually, quarterly, or daily. So yes, most of these problems will be word problems, but honestly, it's just sifting through the information and knowing what pieces belong what. So let's start at the beginning here. A sum of $1,000 is invested. So that right there is what we initially invested. So by definition, this right here is our principal. It's invested at an interest rate of 12% per year. Well, that's very easy because that's a percentage and it clearly said interest rates. So that right there will be our R. Find the amounts in the account after 3 years. Well, duh, that's pretty simple. You guys should know what 3 years, what variable that belongs to. That's time. If the interest rate is compounded, so now they're talking about compound, and the number of compounds will be n. So we have to be able to read this word and understand what n means. Letter A, annually. Well, something that happens annually happens once a year, so that's n equals 1. Quarterly, quarters, that's 4 times a year. Daily, assuming there's no leap year, is 365 days. So then all you got to do is, I hate to say it, but plug and chug. So let's answer this question here. Letter A. So the interest rate formula is A equals P, 1 plus R over N to the NT power. Just plug everything in. They gave us a P, which was 1,000, times 1 plus R, which is 0.12, over N, which is 1, raised to the 1 times 3. That's it. That's all you got to do. And just pop that into your calculator and see what you get. Now, when it comes to rounding, when we're talking about money, always round to the cent. So that's going to give you about $1,404.93. If we did part B, again, it's the same formula. Plug in everything that they give you. So the initial principal is 1,000. 1 plus the interest rate is 0.12 still. The only thing that's different is N is now 4. So that's the only thing that's changed. Pop that guy into your calculator, and you're going to get about $1,418.52. Slightly more money. C, what if I did it daily? Same formula. And pop in everything they give you. $1,000. 1 plus the interest rate is 12. Daily is 365. Pop that into your calculator. You're going to get about $1,433.24. More money. Mistype that. You're going to get $1,430.77. There you go. A little correction on part B as well. I guess I typed in the wrong thing. That should be $1,425.76. So I guess the hard part about these types of questions is make sure you type in the calculator correctly. So that's all compound interest is. It's just breaking apart the regular interest rate into smaller pieces, but you make the number of years or you make the time longer. Now, there's something in the world of finance called annual percentage yield, right? Because compound interest, some people will admit, it's sort of complicated to them. You take a look at any, bank loan statement, any credit card statement, and people don't really talk about compound interest. They just want to, brass tacks. How much interest are you charging me? So what annual percentage yield is, if the compound interest was simple interest, how much money am I really being charged? Right. So let's go ahead and write that down. So the annual percentage yield is trying to figure out what the added percentage is to the number one. Let's go ahead and just do an example. I think it'll be a lot more clear if we do an example here. So for example, if I said find the annual percentage yield for an investment that earns, if I can spell earns, an interest rate of 6% per year, compounded daily. Okay, this seems like a pretty simple question. Let's sniff out all the information they give us. Clearly they give us an interest rate, so that's an R. Compounded daily, that's an N equals 365. Let's see here. Now, this is sort of like very, very subtle, but annual percentage yield, almost always, I'm going to say it's 100%, always time equals 1. So we don't have to worry about time because annual percentage yield will always be 1. Now, the only thing that's missing is they don't give us the principal, but for these types of problems, it doesn't really matter. Why not? Let's just go ahead and do the formula. A equals P times 1 plus R over N to the NT power. I'm going to plug everything in. P times 1 plus interest rate is 0.06. Compounded daily is 365. 365 times 1. Right? So what you want to do is actually, in your calculator, type all this stuff in without the P. Because notice the thing that I'm highlighting. Oh, that shouldn't be a T, that should be a 1. You want to type all this guy into the calculator because the thing that I'm highlighting is just numbers. There's no variables. So that should give you a number. So if you pop that guy into a calculator, you should get about 1.0618%. Well, remember what we started with in terms of the simple interest formula. Remember how we started with this formula here. So basic interest will always be your principal times 1 plus an interest rate. That is what we're looking for here. So basically what you want to do is take a look at this number here and you want to strip off the decimal. So would you guys agree that this is the same thing as P times 1 plus 0.0618? Well, this guy here, the extra strip off, that is your annual yield percentage, or annual percentage yield, APY. Right. So what is 0.0618 as a percentage? That's about 6.18%. So that's how you find your API, and that's what your credit card companies will advertise. So they may advertise, oh yeah, we're charging you an APY of 6.18%, but you may not be charged that 6.81% all the time. It might be compounded daily, monthly, yearly, so on and so forth. So that's basically the second half of 4.1, using this specific formula, compound interest formula, to solve problems.